So this is the code for what we were talking about earlier in our lecture. In this example, we're creating a clock radio. We're using the C++ feature of multiple inheritance. So we have, I actually threw a switch on for constructors and destructors to run. So let me just shut these switches off. If these are set to 1, then the constructors and destructors will start printing stuff. Okay, so our electronics class goes like this. We have a class. If a method has the same name as the class, that you remember is the constructor. I have a routine called output string, and it'll print this out if the variable constructor is set to 1. That's what that routine does. So we can turn that on and off if we want. When we go to create an electronic product, the electronic product has a field, a protected field called integer. So I'm making serial numbers integers, keeping it simple. It's a protected field, so what, just as a review, what is a protected field? A field that is not accessible to the outside, but can be inherited. And this class, by virtue of the fact that we have a virtual function that is equal to 0, this is a so-called pure virtual function. You don't actually type in the word pure virtual. So it's a so-called pure virtual function. And actually we'll make the compiler spit out the word gives an error and say that it doesn't contain a virtual function later, pure virtual function. But anyway, the existence of this function, if you have one or more of these, that makes the entire class abstract. And if you remember, if you've taken Java or C#, you would actually say the word abstract in the class definition. So what is an abstract class? A class that you could never instantiate. You could never make a variable of type electronics. It's just meant to be inherited from. You're not supposed to make things from electronics. But there are some real fields. Like, for example, we have a serial number. And we also have a company logo. So just a little refresher of what a static is. Remember the difference between a static and a non-static field?
That's how you can share, and non-static, it's local.
Right, so if we start making products, if we start making clocks and clock radios, they'll all share the same exact logo. It's whatever our company logo is. So each one won't have its own individual logo, it's just one for everybody. But each one has its own individual serial number, which I guess makes sense. And then what I wanted to do was I wanted to have another static variable called the next serial number. So we're going to start the serial numbers off with a certain number. And for example, I created here, I said for electronics, I used the scope, the 2 colons, saying the electronics class has a field, which is a static field, one for the whole class, called next serial number. And I started off at 1001. Now what will happen is if any object of type electronics adds 1 to it, they all will be incremented by 1 because they're all actually sharing the same field. So anything static, all the electronic products share the same field. Anything not static, they get their own individual copy of the field. So everyone will have their own individual serial number, but they'll share the company logo and they'll share this common variable called next class. I'm sorry, next serial number. Okay, and then there's a method called display data. And all that does is display whatever data makes sense for this class. So here I'm just displaying the serial number. Other data for other classes will also be displayed if they have a method called display data. Okay, so that's the electronics class. Now the clock class. The clock class inherits publicly from electronics. Publicly, if you remember, means everything that's in the public section of the electronics class gets moved into the public section, right? You can never promote, but you can demote. And public inheritance, which is the most common, doesn't do any demoting. So the public stuff gets inherited into the public section, the protected stuff gets inherited into the protected section, and the private stuff from electronics, which happens to be none, but if there was some, would not get inherited at all. Okay, so we have a clock constructor and a clock destructor, and just prints out. Doesn't actually do anything. This routine, I'm sorry, this class, clock, does have a method called power-up. In fact, it has to. If you remember, the power-up in the base class was pure virtual, which means if you inherit from it, you better overwrite the method, otherwise this class clock would become virtual. I'm sorry, would become abstract, which means you couldn't instantiate this either. So we had to go and write power up, and what happens when we power up? Well, we say we're powering up, and we set the hours to 12, the minutes to 0, the seconds to 0, and then this happens to be an alarm clock. So we set the alarm hours, minutes, and seconds also to 0. So the data is hours, minutes, and seconds, which are integers, and then alarm hours, alarm minutes, and alarm seconds. That's all the data that there is. Okay. Now, clock happens, we threw in a method just to be able to do something that is specific to clocks. We have a method called set time. The set time variable, you can set the hours, minutes, and seconds. So just a little review, this h equals 12, what does the equals 12 mean? Because we're actually taking in variables. Someone can set the clock to 2:30 in the afternoon if they want to, so, but why do we have these variables?
It's not like default values, so you don't have to set them instantiate.
They're defaults, right. So if you just called set time and didn't pass in any parameters, even though this is looking for 3 parameters, it'll set the clock to 12 o'clock. So if you just say set time and don't give any data, it'll set it to 12 o'clock. If you say set time to 30 and leave the last one out, it'll set it to 2:30 with 0 seconds. So it'll fill in defaults, whatever you don't give. Okay, and then I have another routine in clock called display data, which prints out clock-related data. Print out hours, minutes, seconds, and the alarms, hours, and minutes. Then we have a method called set alarm. You could set the, it'll take in hours and minutes and set whatever you give it to hours and minutes. And if you don't give it date, I set it to 0, which is not a real time. Well, that's a good idea.
Zulu time.
Yeah. But, oh, actually, the clock will never, the alarm will never go off because it'll never be 0. There's no 0 out, right?
Unless you're doing it on a 24-hour cycle.
Then
Unless
we
you're
give
like
minutes.
military time.
Yeah.
Yeah,
Okay.
yeah, military time.
Then it would go off.
Then we go off at midnight.
Okay. But, okay, and then check alarm would compare the time of day to the alarm and will tell you should the alarm go off or not. And then sound alarm says a buzz. Right now it just says buzz. Okay, so the radio class, similar idea. Radio started off with an enum, that's an enumeration. So I make this variable called modulation, and the only two values you could set it to are AM and FM. Okay. Then we have the radio class, which inherits publicly from electronics also, and it has data related to, pretty much a similar class, except it's radio related. So when you power it up, we set the volume to 2, we set the radio station to 10:10 AM. I guess that's part of our power up. And you can set the radio station, you can pick a number and then an AM or an FM. We have a method also called display data, which will tell us what the data is currently set to. We can increase the volume or decrease the volume. Would it make sense to have a set volume? Or should it just go up and down, like a knob going? I guess either way is okay.
Are we trying to make this easier, or are we trying to make this like a real radio? Because on a real radio, you would have to go incrementations.
Right, because you'd make the volume louder or lower, and then
Yeah.
that would turn into calling methods saying add one, add one, add one each time you
Yeah,
spin
even
the
if you had
knob.
like a button instead of a knob, you still have to go by.
Right, but or if the volume was currently 2, can we just make it 8? Or do we go 2, 3, 4, 5, 6, 7, 8? I guess.
For convenience sake, you could set volume, but if you wanted to mimic a real radio, you'd have to have the increment.
Right. Okay, now the last field, not too much of a surprise, is the clock radio one. So we start listing where we're inheriting from, and you can just build a list in C++. And so we publicly inherit clock, we publicly inherit radio. we have a clock radio constructor, which is actually setting the alarms to 0. And then it also has a power-up routine. And what does its power-up routine do? Well, it calls its subclass the clock's power-up routine, then it calls the radio's power-up routine. So this will set the clock to 12 o'clock. This will set the radio to 10:10 a.m., whatever the default, and the volume to 2, whatever the defaults are. And then we can do our own power-up stuff. Okay, and now, anything interesting here? Set alarm station. So there's going to be a new field where we have an alarm radio station. That wasn't available to the radio because, I'm sorry, that wasn't available to the clock alone because the clock doesn't play a radio. So we can add more data to what we've inherited. And then we've overwritten the sound alarm. We inherited a method from radio called sound alarm that went buzz. Now this one, we're overwriting it saying which is going to play the radio. Right? Obviously the real code here would be like you'd have to kick off the playing of the radio. Okay, so this is set up to work.
Professor,
Yeah?
why do you use the enum type?
For AM, FM?
Yeah.
I think I was just using that just to use it. I mean, if you had a variable that should only take on certain values, like season of the year, you know, winter, spring, summer, and fall, how would you represent that? I mean, you could do an integer and do 0 through 3, but then if people are reading the code, you'd be like saying if season equals 2, then do fall-related stuff. And sometimes people want to see the word fall. So does, I forget now, does Java have an enumeration?
Yeah.
Okay, I don't know if they took that out, but, so you don't have to do that. It's more of like easier on the eyes.
Oh, okay.
So basically we're saying the modulation is AM or FM. Could have made it 0 or 1. No, 0 means AM and 1 means FM. Okay, so now if we created a clock radio and a clock, and I displayed their data, right? So all I'm doing right here is just creating a clock and a radio, and I displayed their data. What would I do? I'd say CR dot for the method, same as Java and C#. And what would we expect to see? And it's,
Don't you mean C?
Yeah.
oh yeah, see, right. Okay, so hopefully this compiles. Okay, so I made a clock radio. I made a clock radio and then a clock. And then displayed what their data is. So let's see. The clock radio I'm displaying first, and I did that for a reason. And the reason is, what are we displaying? Display data of a clock radio calls display data of a clock and a radio, right? And those ones call, why is it running out the serial?
Oh, yeah.
Probably lost the internet connection.
What's that?
You probably lost the internet connection. Because you have remote access and did a rock hopper. It happens to me all the time.
Yeah,
You
it's
can't
probably
get
a
into the screen.
little hot.
Yeah,
So what, does it come back in a second?
No.
Usually not.
Yeah.
Usually gotta close it.
You have to reestablish the connection.
So just log off?
Yeah, just closing it, open back up.
Okay.
I blame Sean.
I blame the government. I blame the compiler.
Compiler is terrible. The compiler definitely won in this situation.
The internet beats the compiler.
Absolutely.
Well, what compiles the internet?
So let's see, we were here. And then
He's gonna hang it in there. It's good.
okay. So where we were is power up from. Oh, I'm sorry, okay, display data of a clock. The first thing it does is it displays data of its electronic components, then displays the clock data. Okay, so that's why we're seeing the serial number. And then, what did we get? We got the first serial number, which I started off as 1001. Then the next piece of data, I don't know what that data is. It was part of electronics. No, that would be part of the clock.
Yeah, it seems to be just the hour.
Yeah,
minutes,
okay, it's hours and minutes. Okay, and then the alarm values. Then we have a serial number 102. And then we see clock radio related stuff. And then we have a serial number 103. Why do we have 3 serial numbers? We've only made 2 products. We made a clock, radio, and a clock, but somehow we got 3 serial numbers. Yeah?
Because it inherited the method from the electronics when you went to go create the clock radio.
We inherited it twice.
Yeah.
Right, from clock, we inherited 1 electronics,
Yeah.
which had a serial number and whatever else electronics had, a logo. And then we also inherited from radio another electronics, which also has its own serial number. And every time we create any of these things, the code was taking that next serial number, which was a static variable, and just copying the number and then adding 1 to it. So every time we create something, we get the next available serial number. So we ended up getting 2 serial numbers. Because we inherited twice, we got 2 copies of electronics. Now, do we want 2 copies of electronics? What's it, a serial number and a logo? It looks like in this case, we only need 1 company logo and 1 serial number, right? So we'd only like to inherit it once. So there's the concept of virtual inheritance. Let's see if they still do a write-up of this. It's a Google's birthday.
13. It's 13th birthday. Yeah.
Wow.
She's old.
You're using that.
Yo, we should have had a birthday party. Computer science department.
What was the one before Google, like Dog Pail or something?
yeah.
Okay, so this is just an example of a Wikipedia, just to not be always focusing on the clock radio. It's good to see someone else's example, but they always use animal. This is like half the time, it's animal and then bird and cat and all that stuff.
Wow,
So anyway, we have a base class animal. We inherit, mammal inherits from animal, winged animal inherits from animal, and then we did a multiple inheritance. A bat is a mammal and a winged animal. So we get a multiple inheritance. And what they're basically saying is, in this case, bat is getting 2 copies of animal. And it's saying that the only way you can refer to a bat is by referring to it as a mammal or a winged animal, because that's what it inherited from. And it gets ambiguous because it's getting 2 copies of animal. And they probably should explain how to get rid of it. So, for example, okay, oh, this is a good point. They're saying that this would not compile. If you tried to say, take bat and convert it into an animal and then have a point at it, it won't convert it because it doesn't know that bat derives from animal, and the reason it derived from it twice. So it becomes ambiguous and it doesn't know that it's that type. But you could say bat, convert that to a mammal, and then convert that to an animal, and this would be okay. But we still have this ambiguity. We have the ability to inherit, when we multiply inherit, and the two things we're inheriting from happen to come from the same base class, we actually have the choice, do you want 2 copies or 1 copy? And the way you can say I only want 1 copy is to do what C++ calls virtual inheritance. I mean, they call it the solution. I don't know if this is a solution or just the other choice. But what we can do is we can say, when we're inheriting mammal, we not only do it publicly, but we also say virtual. And do the same thing for this, virtual. So that means if these two ever get combined together, the fact that they have 2 copies of, they both inherit from the same animal class, only 1 copy would be taken in, and then we could say a bat is officially an animal, because it only inherited 1 copy, so it derives directly from it and there's no ambiguity. So, if we decided that we wanted to do the same thing, we're putting in the word virtual. So this is another use of the word virtual. It's a keyword and has 2 different meanings. We can say, when we inherit, we would say public virtual electronics. And we would say, do the same thing for clock. And now we say, throwing in those 2 words, so we should only have 1 serial number. Yeah, so now now the clock radio only has,
It calls it twice, but it still only has 1 serial.
101, 102.
right, so we
The
had,
second one's the second object.
oh, that's right, yeah, so it showed up twice. So here's what happened, the clock so what we did was, we had the bottom of this thing. That's the bottom. Okay. So we made a clock radio, and then we made a clock. When we displayed the data of the clock radio, the clock displayed the electronics data, which is why we got the 101. Then the radio went and also displayed the electronics data. So we probably would like to not display that twice, but that display data, that's our own method. That's not the one that the compiler's giving it. So that's why we end up getting the data twice. We could probably put in some code that says something like, we probably want to rewrite it in the clock radio, so just so you don't see the same data twice. But that's why it came out, 101 came out again here for the clock radio, and then 102 is the next one. So now we only created 2 different serial numbers. So putting in that word virtual means what you're basically saying is, if you inherit virtually, if some other class also inherits from that same base class, and then someone multiply inherits, you'll only get 1 copy of each. And we have the option. Again, C++ gives you a lot of options. We have the option to inherit 2 copies or 1 copy. For example, if we wanted to do as part of our assignment, if we wanted to have a radio with a volume field, and a CD player also with a volume field, and you decide you want to have 2 different volumes, one for the radio and one for the CD player. Maybe you want that. You like the radio to play loud and the CD player to play low or something. You can decide, I want 2 different volumes, and then don't inherit virtually. So it's another option we have. So now suppose, what would happen, let's see, what else can we do with this code? So this is good, like, just code snippet to play around with. Suppose we wanted to let's say here's a test question. Suppose we wanted to create an electronic. What would you expect to happen? Compile, run, any issues?
Compiler.
What's the compiler error?
Can't make
What's
it
the abstract?
That's an abstract base class. So what do you think it would say?
Segmentation fault, I think.
Computer blowing up.
Oh,
Whoa.
I didn't state it, hold on.
Oh.
Right?
That's a true compiler.
It's like, we're all wrong.
The virtual function.
It was time to go home. Let's see, variable E
Power one.
is,
Or we beat the
cannot declare
compiler.
variable E to be an abstract electronic because, oh, so it even says the word pure virtual
Nice.
in the compiler error. So it says the virtual functions are pure in electronics, and then it gives the one example, power up. So it's saying power up is a pure virtual function, therefore you can't do this. So can we do this? Let's just think of questions that could be on a test or a job interview. Could we do this?
Pointer.
Would this compile? So what are we doing here? I'm creating an electronics pointer. Now electronics is an abstract class, but can I create pointers to an abstract class? A pointer is just a field that has an address to something else.
I think it would work.
And then I created a clock radio, and then I said the pointer to the I should have made an EP, but yeah, I'll change it, EP, just to be consistent. So, and then I'm saying that pointer is pointing at the clock radio. Can I do that?
I think it'll work.
Yeah, I think it'll work.
And also, what if I did this? Okay, wait, but let's just see if I
And then point it back.
But why would you be able to point to a piece of storage of a class that you can't create a piece of storage for?
Let's see.
Because it's
All right,
C++.
so,
Did you save it?
Yes, he did.
Oh yeah, you had to save it.
okay, so now, can I do this?
Point
Should I be
back.
allowed? Okay, so now, once you have a pointer to something, if you want to refer to, you know how, if you want to call a method on a reference, you would say the reference dot and the method name. If you're using a pointer, you have to use an arrow. So you go like this, you say arrow. Now, should I be able to call set time? Should I be able to set the time of day to 4:30 using an electronic pointer, which happens to be pointing at a clock radio at the moment?
Yes.
So what do you think?
Was your
Maybe.
set time,
There's no compile, we'll see what happens.
set, take
Just
two
take
variables
compile,
or
let's see
three?
what
Did you have it set up for?
What's that?
Did you have
Right,
set
let's
time
see
set
what
up for
happens.
two
I'll
variables
let
or
you know.
three?
It was set up for,
Trial and
this was set up for 3 variables, but they had default values, so if you put in 2, it'll fill in the last one for you. So this would work, but do you think we can call a clock-related function on a clock radio using an electronic pointer?
Probably can, but you won't like the results.
But would the compiler say, yeah, if the compiler allowed this line to run, the compiler's saying, I know for sure this electronic pointer will always be pointing at a clock, some kind of clock, a clock radio or a clock CD player radio. And could it know that for sure? It might just be pointing at a radio. So this one should not compile. So let's see, I'll save this one, and it should hopefully say that there's some kind of, type mismatch problem. So Glass Electronics does not have a member called set time.
Yeah.
Now, So now what some of you guys were saying is, okay, this is allowed, but what's the point? Well, could we call power up?
You might be able to
Yes.
just
Yeah.
like local.
Because
Power up.
electronics
Yeah.
has a power up method.
Yeah.
But then which power up method?
And, right, and now the question becomes, which power up should run?
Didn't we go over this
We'll
last
look to
class?
see
Yeah,
if
there
Right,
there's
we
a
kinda went over
method
this.
available from the virtual.
Oh, yeah. the
And then if
virtual,
there's not,
okay.
we'll just take the base class.
So, right, so now what we have,
Yeah.
Clock radio's power up, I think will run.
Pete's got it.
Pete's on point.
so wait, well, what would determine it? So I'm gonna use, okay, so here we have an electronic pointer, happens to be pointing at the moment at a clock radio, and I'm using the pointer to call power up. What determines whether we use the electronics power up or the clock radio's power up?
For
Virtual.
If virtual appears where?
In the
in
electronic.
In the electronics one, because the base class person should have control over it, not the inherited class. So,
If it wasn't virtual.
it wasn't?
No, I'm saying if
Was
it
this
wasn't virtual,
Oh,
it would.
yeah.
Oh, but it's actually pure virtual. It's virtual and it
Oh.
equals 0, meaning you're forced to rewrite it.
Yeah,
So
so
it has
it'll
no
run
choice.
the yeah, run the clock radio.
Yeah, this, okay, and this goes,
Power up.
Clock radios, power up.
and which calls clocks power up and radios power up and then clock radios power up.
So it did all.
Everything's gone.
So that should power up everything. Right? Okay. So what other things can we do?
Can we see-
Okay, now, so now, suppose we wanted to make an inventory of products.
Take out virtual and see what happens.
Yeah, I was saying, assuming it wasn't a pure virtual,
Yeah,
it would run.
take-
Then we would run the base
the
class.
Yeah.
Oh, yeah, let's do that, just to convince ourselves. Let's see, where is equal 0? Here it is.
Yeah.
Suppose
So
instead of
before
equals
ran the clock
0,
radios method,
I
Yeah.
made it a method that said cout
Electronics.
Power on or something.
electronics power up.
Yeah.
There's an IC in there.
Okay. So will that compile?
should.
Should.
See my answers.
So wait, so we want to take away the word virtual.
Oh, yeah, yeah, get rid of virtual.
Where are we? Here.
Yeah.
Okay, it's not virtual.
So now it's not virtual, save,
So that means right.
and,
Should compile.
It should compile.
Ambiguous.
yeah, compiled, and,
Nothing.
Yep, electronic
Whatever.
power.
Oh yeah, there it is.
oh, I didn't do a new line, okay,
Boom.
electronic power. Okay, now suppose I put the word virtual back in, it shouldn't be a big surprise here.
Just do the same thing as before.
Not necessarily, it's gonna check if it's there, and if it's not there.
Oh yeah.
What's that?
Well, yeah,
Do
it's
we
still-
Yeah,
rewrite
now
the
it's not
method?
now it's not
Do
a
we-
pure virtual function.
Yeah, but
It's
we-
not pure virtual,
but it is
Yeah, but if
virtual.
we
It's
read a
virtual.
power up method within that,
But since
clock
there's,
So the
radio?
last one.
Yeah.
called
oh yeah,
one
we're
method.
good. But if we didn't, then it would call the base.
yeah.
Yeah.
Okay.
so if we're using, the way we're referring to it with a pointer, if that's the type of the base class, and we call power up, it's basically going to, we talked about that V pointer, it'll point at a table which tells where the methods are. It will come here and basically check, is the word virtual here? If so, then go look in clock radio to see if the method's there, and if so, then run that one. If not, come back here and run this one. So,
Sounds complicated.
well,
Commit the second one out.
I mean, just because you put the word virtual there, if it's not, if this method is not pure virtual, the class inheriting it is not required to write it. It has the option to change it, but it doesn't have to. So if the word virtual is here and the one you're inheriting doesn't have one, then you have no choice but to come back and run this one. But the word virtual here is just saying check for a matching name whenever you have a reference, not of the same type of the object being pointed at. So this should. Yeah, so we threw in the word virtual, and then that made the one of the class we're pointing at run.
If you put virtual and clock and radio's power up, we'll skip them over. Just put clock radio power up.
think of the word virtual as search. It'll just
So
find.
it'll just keep going down, right?
Yeah. And now we should be able to create an electronic, right? Because we took out, right? This should now compile if we, so for example, I should be able to create an electronic. This didn't compile before because we had the pure virtual function that equals 0. We don't have it now. So this should now compile. Because now we can instantiate. Whoa.
Electronics was not declared in this scope.
Forgot the R in electronics.
Oh. Okay. Okay. Okay, so this is now compiling. So let me just set it back, so when you guys copy this, you can do your assignment.
Should be fun stuff.
Things don't understand.
This was equals 0, and that was virtual. And that's a so-called virtual function.
Semicolon.
Ah, good, good. That would
You
have
got-
given everyone a
oh,
compiler.
equals 0 makes it
Yeah.
weird. Oh.
So now if I compile it, that E should not compile.
Still have to say that. Yeah.
Oh,
Still didn't compile.
It still gave a virtual error. Or some kind of
E is
virtual error.
abstract.
Yeah,
That
because it
makes
calls
sense.
it.
Okay. So that's because this line at
This
the
isn't
bottom.
pointers.
No, it's this line.
Yeah.
Now that that's. Okay, so now suppose we wanted to make an array of these products.
Import Java package or array. Oh wait.
Can you import stuff like that? How you do with Java?
You can do, you can include files. The
Do they
header
add
files.
packages?
No, but you can include header files, so if someone else had a file, you include it.
Pound include your file name. of
Right.
course.
So let's say we had a clock radio, and then suppose we had a
Everything.
clock. And then we had a
It's
radio.
like, I would hate to not use a method because not packaging it all. Import all.
Every time.
I feel like it's probably not good to do that
No.
because you're importing more than you have to.
Import everything,
Or whatever.
just in case.
You never be too sure. You know, with unit system testing, you don't know what can happen. So.
Okay, so I'm making an array of product pointers.
Was that star do or
No, well, we're saying the type is pointer to electronics, not an actual electronics, but just an address that points to an electronics.
okay?
And then,
No class.
so here I'm saying I'm making an array of pointers to all the products we make. Let's see if we can do this with no compiler error. Right, does everything looks good so far? It
No,
made it-
aside from no
semicolon.
What?
For array, so.
Oh, okay. Okay, now, for int I equals 0.
Oh, the loop looks the same.
For loops are for loops. There's not much different you can do.
Make it a while with.
I haven't done one of
Best
these.
loop is for.
I always copy these from somebody, is that correct?
Semicolon, semicolon. It just runs forever.
Everything.
Set world on side, and then set world on.
So that's the pointer.
Right, goes on fire, set the one, is on fire, set the one on fire.
Would this work? No. Think no compiler errors?
What does the arrow do again? I'm sorry, I didn't write it down.
No, it's no problem. Yep. So if you're using when you use, like, and you know this from Java, if you use a reference, if you're referring to an object and you want to call one of its methods, you would say the reference dot, the method name, right? If you're using a pointer, they probably should have let it be dot too, but they just want you to spell it out. Oh, I understand, this is a pointer, so this is like an arrow, like this thing is pointing at the method of that one. So this is a pointer. The thing being pointed at by this, call its power-up method.
So basically, it's the same thing as the dot, but the fact is that you're using a pointer.
You're using a pointer rather than a reference. And they really didn't have to do that, they're just spelling out, you know, so now
If you were
somebody could
using a
read.
reference, it would be a dot still?
Was it?
If you were using a reference instead of a pointer, it'd still be a dot?
It would have to be a dot. So in C++, you have a choice between a reference and a pointer, and in Java, you don't have a choice, it's reference dot method name. Here it could be reference dot method or pointer arrow method.
Awesome.
Yeah?
Yeah, it's electronics, a type, and then you have the electronics. It should be capital E.
Oh, yeah. That would have had a compiler. All right, so
There you go.
well, like,
Moses coming out.
I'm trying to say, yeah, let's see if we can pop.
Oh!
Anything else before we?
He's the new compiler.
We all lose 1 point if there's no, if there's a compiler. Anything else you think will compile? Not compile?
I don't know.
Let's see. We'll let it rip. Yeah.
Whoa, everything's powering
So yeah, we're going through the array.
We're turning
just-
2%.
So the first three are just the
So,
one.
the clock radio.
Yeah.
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 This is the clock radio powering up.
Yeah.
This is.
Yeah.
Radio.
That's.
Wait, why'd that happen? Oh,
First,
okay.
because
So I got them back. Okay.
And if you were to, let's say, for example, call the electronic power up, you would have a compiler error because it's abstract?
Actually, we couldn't. We can't create one. Now that it's abstract, we couldn't even make one. Here's where we're making the three objects. This is like getting a chunk of storage, running the
Yeah.
constructors. Then here's where I'm creating 3 pointers to point at them. And now I'm setting the addresses, and now I'm running through all our products and just turning them all on. So we couldn't create an electronic because it's abstract.
Yeah.
So, like, what you were saying was, could we point at an electronic and power it up?
We
We
can
can't
compile
even
it.
make one to
Yeah.
point at,
Okay.
so. Okay, so now if I ran the, what was the other one, display data? So I could run through all of these and display the data. I could power them up and display the data.
It's like similar but different.
Makes you appreciate what we have now.
Oh, I still
Java, I
don't
love you,
appreciate
Java. You're the best.
You go to bed every night praying, thank you, Lord.
For the invention of Java.
Yep.
Do we have other data?
Just read them. You got so many power-ups.
No, I think the other stuff comes.
You have,
One,
you
two,
have
three.
clock, radio, and
I
clock.
was saying, isn't that other stuff supposed to come up with power up?
No, now I'm doing the same thing, but I'm displaying all the data. I thought it would be like, what time is it, and what's the clock?
But isn't it the electronics pointer, so isn't it just the electronics
Yeah, it's
display
just a
data?
pointer.
Which would just be the serial number?
Didn't even print the logo.
He never printed the logo. When he did display data, it's just displaying the serial number up top.
Yeah, it's only called the electronics.
Yeah.
It's only calling the but they all have display data.
Not virtual.
But you're not, are you calling
The
display data?
electronic
you're just
one
calling
isn't virtual.
Power.
Yeah. These are
Oh,
Yeah.
The electronic isn't virtual, that's what it is.
Yeah, electronic only displays
okay.
data.
Oh, okay. Was it virtual before? Did we take it out?
No, it was never virtual.
Okay. Now what should happen?
Who's gonna call those other guys?
Yeah,
Now, okay.
all the other data is
Call
going
it
from
friends.
Yeah.
Parts, boys.
So, yeah, now they should all start being called,
It's all
right?
about
Yeah,
ownership.
here's all the junk coming out.
Oh,
Okay, that's what, I don't know why I left it unvirtual. Okay, but just so that we learned that concept again. You put in the word virtual and then all the matching name routines. It doesn't go based on the pointer, it goes based on what's being pointed at, ends up being called. And then, as far as constructors and destructors, this code has, I'm just gonna create 3 things. This will be the last demo. I won't display anything. I'll leave that in if you want.
Stones, the power of stones.
I'm just gonna make 3 things, and I'm gonna turn on the constructors and the destructors. So what, if you know, we're being asked this on a test or a job interview, what constructors and destructors run? So I'm just gonna turn, these are flags I set. So if we save, so this is basically gonna tell us what constructors and destructors ran. So before I run it, what order do you think the constructors and destructors would run? So I'm creating a clock radio, then a clock, then a radio. So the rules were for constructors and destructors, base class first, derived class second for constructors, and destructors are always the reverse order of the constructors. So what would you expect to see? Electronics. Then it'd be, if you're inheriting 2 things, it's the order in which you inherit them in. So we inherited clock first?
Yeah, clock first.
So it should go electronic, clock, radio, clock radio.
Clock.
And nothing's destroyed yet.
No.
Then electronic, clock, electronic, radio, and then whatever we just said in reverse order should come out as destructors.
You wanna do it backwards?
That'd be like a good, you know, drunk driving test. Nope. So did we get it right? It was, so this is the clock radio. Electronic, clock. Yeah, we didn't do a second electronic because we inherited virtually. So electronic, clock, radio, clock, radio.
Electronics, clock.
Then we did the clock. Electronics clock, then the electronics radio, and this should all be, this should be like I'm putting a mirror there.
Yep.
Yeah.
Yeah. Okay. So that's always a popular job interview question. Given some code, what order will the destructors run in? And the way you solve it is figure out the constructors and then spit it out backwards.